Hi, and welcome to Percent Error. I don't have a helper today, so I'm going to be trying to push the button myself. There's going to be some lag time. So we're in Chapter 2 now of Honors Chemistry, and I think this is in Section 3 of Chapter 2, but it's a very simple calculation. It's about percent error. So when we do an experiment, if there's a known value, we call that the theoretical value. That's the one that everybody decides is the correct answer, or the most people have gotten that answer. That becomes the theoretical. Experimental is whatever you get. So when you're done with the experiment, you get an experimental value, and you want to see how close your answer is to what it's supposed to be. We try to shoot for less than 10% in honors chemistry, but sometimes that doesn't work out. So I'm going to do one example problem. Like I said, not too hard. Theoretical is what everybody thinks it is, and experimental is what you get or what the experimenter gets. So as an example, the theoretical or accepted value for gravity at sea level, the acceleration due to gravity, is 9.81 meters per second squared. And by now we've become experts at significant digits, so that has 3 significant digits. Let's say that we do an experiment here in Beckley, West Virginia to find the acceleration due to gravity, and as our experimental value, we get 10.01 meters per second squared. This is the accepted value, this is what we got, and we want to see how close we are to what we were supposed to be. So we do a percent error. We take the theoretical value, 9.81 meters per second squared, and we subtract from that what we got, 10.01 meters per second squared, and then we divide by the theoretical again. So that's going to be the 9.81 meters per second squared. We take the absolute value of the top part so that we always get a positive answer, and when we're finished, we take that fraction and we multiply by 100, and that's what makes it into the percentage. Just like any other percentage, it's the part divided by the whole thing times 100. So I'm going to take my calculator, 9.81 minus 10.01, I get my answer, and then I divide by the 9.81, and I multiply by 100. Remembering to take the absolute value so I get a positive answer every time. So the percent error for this particular experiment is going to be 2.03%. Notice how I have 3 significant digits, because although I subtracted and divided, I'm going to follow my rules for division at the end and only have 3 significant digits, just like the theoretical value only had 3 significant digits. That's how you do percent errors.